So on the market today, we have a green energy called renewable natural gas or biogas, and it is produced through the anaerobic digestion process like Jack was just talking about. You feed some food waste, you feed some sugar to these digesters, and you get this green fuel that is about 60% by volume methane and 40% by volume carbon dioxide. Now, if you clean that carbon dioxide out, you can use it as a replacement for traditional natural gas. But if you're trying to remove it from the site that you produced it, you try to go transport it, you try to store it, that's when it becomes an economic burden. So we need an alternative use of this methane gas, preferably one where we don't have to clean the carbon dioxide out of it, because that is another cost burden for the process. So there is a group of bacteria called methanotrophs, and what they do is they metabolize methane gas and oxygen, and they produce a storage product called polyhydroxybutyrate, or PHB. They also don't care if there's carbon dioxide in the environment, so you can just pipe biogas straight to these bacteria and you don't have to clean it up. This PHB polymer is biodegradable, and it has properties that rival those of polypropylene. Polypropylene is the second highest produced commodity plastic in the world. Lots of labware, your centrifuge tubes, your pipette tips, even potentially the pen that I have in my hand can be made out of polypropylene. And we know that these plastics come from, as a byproduct of the oil refining process, they don't degrade well in the environment. So having some sort of biodegradable replacement, or at least substitution of this into this plastic market, is very, very important. So kind of looking at this cycle, you start with a digestion process at 1, you make some biogas, you send it over to these methanotrophs, you make your PHB, these granules, and you can turn it into products for use in medical applications. It's used for internal suturing. The body doesn't reject it like a metal plate would or a screw. It's also good for like labware or other commodity plastics. And the best part about it is that because it's biodegradable, you can throw it away, it goes in the landfill, it biodegrades. Or you can throw it back into an anaerobic digester and use that as a feedstock for more biogas, and then turn more biogas for more PHB. So it's a cradle-to-cradle process where you're creating some biogas from waste, you're using that as a feedstock for a more valuable product, and in turn, once it's been used, using that as a feedstock for the original feedstock, biogas. So researching these methods of optimizing methanotroph growth and the modeling of how they grow kinetically is important for trying to determine how much PHB we can make to make this a sustainable process. Thank you.